Hello, my name is Mrs. Taylor, and today we're going to be talking about position versus time graphs. This is actually a three-part series. This is part one of the three-part series. So we're going to have one on position graphs, we'll have one on velocity graphs, and then we'll have one on both velocity and acceleration graphs together. If you haven't already taken a chance to start looking at the sheet you see in front of you, you need to stop the video right now and take time to do that because you need to have read and started to think through this prior to listening to the video. Also, the nice thing about the video is at any time you can stop it and listen to the things again so that if you really just need to hear something one more time or two more times or 10 more times, it's there for you. So I'm going to be working hopefully right alongside of you or to verify or affirm the things that you have already been doing. So the first thing is, I'm just going to grab a smaller pen so you don't need to worry about what's in the lower left-hand corner. On the axis, we're going to label the following. So on the x-axis, I'm going to label that with time in seconds. And then the y-axis, we're going to label with position. And remember, we use the letter x for position. And we will use the unit of meters. We will label the zero position. And that is also known as the origin, which we measure all of our positions from, or that's our reference point for all of our position measurements. So number 3 says to sketch position graph for an object whose position is increasing as time increases. So that means as time goes up, my position is also going to go up. So when I combine those two ideas together, I'm going to end up with a linear graph that has a positive slope that looks something like this. We know that this has a constant velocity because for each, let's say 1 second in time, the position changes by the same amount. This object is moving away from the origin. So we'll label this with constant speed away from origin. And then number 4 says on the same axis, sketch the position graph for an object moving toward the origin at a constant speed. So we know that that 0 on our position axis, remember, is the origin. So as time increases, our position is going to decrease. That's going to look something like this. And that slope is negative. This means that the position is decreasing as time increases. And we will label that, so I'll put a little arrow next to it to make sure that we know that this is toward origin. And that, again, is moving at a constant speed. Number 5 says, what does the sign of the slope of the position graph tell you about the sign of the velocity? They are the same. And we know that because the slope of the position graph gives the velocity, right? That's our definition. That's our definition that we've been working from since we started this. So now that we've looked at velocity that is constant, we're going to start looking at velocity that is changing. And when we have a changing velocity, that's going to cause our position graphs to be curved. So again, we're going to go through and label. And we need to include our zeros, right? We're going to include our zeros. And we're going to sketch a position graph for an object moving away from the origin and speeding up. We'll label that as well. So this is away, speeding up. Sorry, I kind of jumped around on it there a little bit there. And then it asks us to draw 2 tangent lines at different points on the graph. And then how does that steepness tell us about how the velocity changes over time? So I'm going to grab my ruler. I would encourage you to grab your ruler as well. And I'm going to take my ruler and I'm going to touch it just at one point. So the point that I'm looking at is that point right there. And notice that my ruler just touches the curve but doesn't cross it. That's our definition of a tangent line. And we look at the steepness of that tangent line. That tells us how fast that object is moving at that instant in time. It's also known as our instantaneous velocity. Now I'm going to choose another point. Maybe I'll choose a point that's further on up the graph, a little bit more, a little later in time. And again, I'm going to draw a line that touches the curve at one point but doesn't cross it, right? Touches the curve but doesn't cross it. So it might look something like this. Now, if you compare the steepness of those two lines, you'll see the second one is considerably steeper than the first one. So that means that the steepness increases, and that tells us that the velocity increases. Because we know that the slope of the position graph gives the velocity. So notice this position graph is talking about moving away from the origin. We're now going to have a position graph that is moving away from the origin, but it's slowing down. So that means that over time it's going to become less steep. So that's going to look something like this. It's going to be steep, so kind of listen as I draw. So it'll be steep, less steep, less steep, less steep, less steep, less steep, less steep, almost to flat. And that is going to be slowing down. Notice I already have a way labeled. Both of those two graphs are for objects moving away from the origin. We are ready, I think, to start looking at, I'm just going to get rid of my ruler there so we don't have to look at that. All right, so now we're going to be looking at a position graph moving towards the origin. So we're going to be looking at that bottom set of position axes towards the origin and speeding up. So remember, when we're going towards the origin, we're going to go from far away, position far away, to close to the origin. That's generally toward the origin. All right, so we're going to start with one that is speeding up toward the origin. So speeding up towards the origin is going to start out fairly flat. Okay, so it's going to start out fairly flat, and it's going to be getting steeper and steeper as time goes on. So I can kind of draw it like this. Maybe that'll help you kind of see that it starts flat and it gets steeper and steeper as time goes on. So I'm going to label that one speeding up. Note that this is moving towards the origin. Both of these graphs, the object is moving toward the origin. My little parentheses on my meter kind of went away, didn't it? We'll fix that. All right, so then we're going to sketch the position graph for an object that's moving toward the origin, but this time it's slowing down. So that means that we're going to have steep, 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 less steep over time. So we're going to start steep, and then we go less steep, less steep, less steep, less steep, less steep over time. So that is slowing down. I'm going to make one quick connection before we end our video today. First, remember, slope of the position graph gives the velocity. So you'll notice in the away graphs here that those slopes, while they change over time, are positive. That's going to produce a positive velocity. If you look at the axis that has motion towards the origin, all of those slopes are negative. That's going to produce a velocity that is negative. I hope this was helpful, and tune in for our next installment of our graphs, and we'll be talking about velocity versus time graphs.